This time we have Thevenin problem. We will start with Thevenin number one. Okay, so what we have to do is we will start with this circuit. There's a diamond here and resistance, another piece of resistance, a voltage source here, another resistance, and this is your terminal A and B. This resistance here is in an amount of 5 ohm. The current that flows here is called I naught. And I naught shows up here in the diamond, such as 13 over 5 I naught. So this diamond is a current dependent current source. This one here is 5 ohm, here is 5 ohm on the top. All right. And this voltage here, let me clean that a little bit right here already. So this is the voltage source, here's a minus. So this is in an amount of 20 volt. Okay, and we have a mesh current here called I sub 1. We have a mesh current here named I sub 2. So let's try to recap this circuit, folks. So we have a voltage source in an amount of plus and minus as shown here, 20 volt. We have three resistors each of 5 ohm as plus. We have a current dependent current source shown by the diamond in an amount of 13 over 5 I naught, where I naught is the current shown in the second mesh. So our end game here is to come up with the Thevenin equivalent circuit and also find the max power it can deliver. So we have to determine what is the Thevenin equivalent voltage, what is the Thevenin equivalent resistance, and what is the max power, Pmax, this circuit can deliver. So these are the target. So let's get started. So if we look at the mesh number 1, we recognize that I sub 1 is 13 over 5 I naught. Okay? And also, in like manner, if we look at mesh number 2, we recognize that I2 is I naught. And the voltage across the terminal PAB is what we called POC, or Thevenin voltage, is given by Ohm's law here as 5 times I naught. Okay? So if we know I naught, eventually in numerical form, we know the Thevenin voltage. So the Thevenin voltage will be determined in this manner. So let's get to it. Let's go with a little heading here, determinism of PTH. So this is our little heading here. If we take the KVL around mesh number 2, we see minus 20, that is the voltage from the voltage source, plus 5 using the house rule, I2 prevails over I1, I2 minus I1 is the net current going upward, plus 5I2 plus 5I2 equals 0. So we can simplify this fellow as minus 4. Well, we are basically dividing by 5 throughout. So minus 4 plus that 5 is gone now. So we have I2 minus I1. The 5 is gone as well. So plus I2 plus I2. Again, this is had by dividing the whole expression throughout by 5 on both sides. So, very simple algebraic process. So we have how many I2s? 1, 2, 3. So 3I2 minus I sub 1 equals 4 by moving the minus 4 to the right side. Now, recalling the fact that I2 is the same as I naught and I1 is 13 over 5 I naught, we can rewrite this expression as 3 times I naught minus 13 over 5 I naught equals 4. So by simplification, 5 times 3, 15 minus 13. So that's 2 over 5 I naught equals 4. Meaning I naught is 10 amp. Wait a minute. This is a little messy here. So I naught is what now? 10 amp. Knowing I naught, we know VAB or P Thevenin as 5 times I naught, so 5 times 10 will be 50 volt. So VAB is 5 I naught, which is 50 volt, meaning we have now the Thevenin voltage VTH as 50 volt. So that part is done. Now, the second part is determination of R Thevenin. Okay, this is R Thevenin. So this is our second part. There are many techniques to determine this. One of the technique is to short circuit the open end. So let's use that technique. Let's redraw this circuit. So we have the current source here, the diamond, in an amount of 13 over 5 I naught. And then what we have is we have the 5 ohm resistor here. And then we have the 5 ohm resistor on the top. We have the 20 volt plus, wait a minute, this gets a little messy here. So we have plus here and minus here, 20 volt. And we have a resistor 5 ohm here. And this was our A and B open-ended. Now, this is what we will do. We will connect these open ends by a wire, and the current that flows here is the short circuit current ISC. Okay, and ISC is the target at this point. Now, when we have this ISC, short circuit current flowing, and there's a parallel piece of wire in an amount of 5 ohm through which I naught is flowing. So we're looking at a situation where the resistance 5 ohm is in parallel with shorted wire. So electrons will pick up this short circuit path, leaving the 5 ohm almost useless. Nothing will flow through this. And we have been saying the current that flows there as I sub naught. So I naught in this case is nothing. So by drawing this ISC as the current that's flowing through this shorted wire, we discover that there is no I naught left. If there is no I naught left, then 13 over 5 I naught is also gone with the wind, meaning the diamond is non-conducting. It is the case when the diamond, which is the transistor, is non-conducting. And that will happen, can happen, has happened here. So the circuit is reduced. We will not even have the diamond anymore. So what we see then is a simplified circuit with 5 ohm here, 5 ohm here, and the voltage source here. The 5 ohm on the right side is not doing anything with regard to flow of electricity, so we might as well take it out. And here is the ISC. So the physics here is pretty interesting. And ISC therefore is from Ohm's law, very simple stuff. This is what now 20 volt source divided by 5 and 5, that makes 10 ohm, giving us the current in amp. So ISC is basically 2 amp. What a nice thing. ISC is also called the Norton current, and the R Thevenin is given by the ratio of the Thevenin voltage to ISC, or the Norton current. The Thevenin voltage was 50 volt, and we just found the ISC to be 2 amp, so we're looking at 50 over 2 ohm. In other words, R Thevenin is 25 ohm. There you go. Let's put this in a box. So we found both Thevenin voltage and Thevenin resistance. VTH is what now? 50 volt. And RTH is 25 ohm. So our Thevenin circuit will look like this. Simple thing, 50 volt, and R Thevenin is 25 ohm. So whatever the given circuit could have done, this Thevenin circuit can do. So that is where the Thevenin circuit comes in as equivalent circuit. So to draw max power here, we hook up the load onto the end here, RL, and RL has to be 25 ohm as well to have the power become Pmax, and this Pmax is given by VTH square divided by 4 RTH, meaning Pmax is, in this problem, 50 square divided by 4 times 25. Okay, this is square here. So 4 times 25 is what now? It's a 100. So 50 square is 50 times 50, so all that remains is 25 watt. Therefore, Pmax is the max power our circuit can deliver is 25 watt. So there you go. This is the end result. Hope you enjoyed it. I had a terrific time working on this problem. Take care.